A warm welcome to all the students. In this lecture, we are going to study a very important lemma called as pumping lemma for regular languages. Now, what is the use of this pumping lemma? It is basically used to prove that the given language is not regular. Okay. Now, many a times for exam, they ask you a question. Prove that the given language is not regular. So, in such cases, it is only pumping lemma that can help you to prove that the language is not regular. Whereas, if it is asked to prove that the given language is regular, then you need not use pumping lemma. To prove that a given language is regular, you will have to try to design a finite automata, or you will have to try to design a regular expression. And if you are able to design a finite automata or regular expression for the given language, you can say that the language belongs to, or the language is regular. But whenever it is asked for you to prove that the language is not regular, I want you all to focus on this word not. Then you cannot, you should not be again trying to draw automatas and regular expressions, because you are asked to prove that the language is not regular. So most probably it is not regular. So you will not get any finite automatas, or you will not get any regular expressions for that language, and wasting time to draw would cost you, right? So whenever it is asked to prove that language is not regular, you can straight away use the pumping lemma to prove that the language is not regular. Whereas if it is asked to prove that the language is regular, you can start drawing your automata or a regular expression, and if you have found an automata or regular expression for the language, it is regular. Okay, so always use pumping lemma when it is asked to prove that the language is not regular. Keep this in mind. Now what this pumping lemma says? It says, given a regular language L, there exists a constant n. It is called as pumping length. So assume that L is a language given to you, then there exists a constant called as n, and that n is called as pumping length, such that for every valid string w in L, such that for every valid string w in that given language L, the length of w, okay, w's length should be either greater than or equal to n. Okay, so if L is a language that is given to you, okay, then there exists a variable called as n, a constant called as n, and that n is called as pumping length, such that for every string w in that language, w greater than or equal to n, okay, it says that this string w whose length is greater than or equal to n, this string w may be split into 3 substrings or 3 parts, namely x, y, z, such that w can be rewritten as w equal to x, y, z. Okay, such that the following condition should be satisfied. 1. Y should not be null. The subpart y over here, it should not be null. The together length of xy should be it should be less than or equal to n, that you have already decided. So the together length of component x and component y, or substring x and substring y, together length of these two should be either less than or equal to n. Then for any m greater than or equal to 0, for any variable value m greater than or equal to 0, if x, y raised to m, z does not belong to L, if you are able to prove for any m from 0 till infinity, if you are able to prove that the string x, y raised to m, z, it does not belong to the given language, then we say that the given language L is not regular language. We go with the problem. It is being asked to prove that the language L equal to 0 raised to m, 1 raised to m, such that m is greater than or equal to 1, it is not regular. Now what do you understand looking at this language? First, 0 raised to m, 1 raised to m. See, m is same, that means number of zeros and number of ones. Okay, here as you can easily see, it is 0 raised to m, 1 raised to m, which means the number of zeros and number of ones in the valid strings in the language are equal. So number of zeros and number of ones in the string should be equal. That is the first thing, because m is same, 0 raised to m, 1 raised to m it is, right? So if there are 4 zeros, the string will also have 4 ones. The second observation that we have is only after all the zeros are exhausted, then only ones will start. So ones will follow zeros, okay, or ones zeros are preceded before ones start, okay. So first we will have all zeros and then we will have all ones, okay. So there are two things that you observe in this valid strings of the language. One, the order is such that first all the zeros should be exhausted, then only ones will start. And second observation in this case is number of zeros, no matter how many they occur, number of zeros will be same as number of ones, equal, right? And another constraint that is mentioned here, m should be greater than equal to 1, which means m can be 1 or more, but m cannot be 0. That means null, when null will occur, if m is 0, it will be 0 raised to 0, 1 raised to 0. And if any sub expression is repeated 0 number of times, what do you get? You get a null string. So it simply means that the null string is not part of this particular language. So let's start, okay. So I will say we will be abiding by the pumping lemma, as we have already seen in pumping lemma. So L is a language that is given to you, so we have to first say let n, that's a pumping length. I just randomly say that let n be equal to 8, okay. Now then let w be a valid string, okay, such that let w be a valid string such that length of w is either greater than or equal to n, which is 8. Now in this case I will say I will take this string w equal to 4 zeros followed with 4 ones, okay. I am just assuming the value of n, and then I have to assume the value of string w, a valid string of the language, and I should make sure that the length of the string, I should make sure that the length of the string w is greater than or equal to n. So if you check here, the length of this string happens to be 8, okay, and 8 is greater than or equal to n. 8 is not greater than 8, but 8 is equal to 8, right? So the length of the string is 8, n is also equal to 8, so this is fine. Now next, let w be split into 3 parts. X, Y and Z, such that w equal to x, y, z, okay, such that the following conditions are satisfied. Are satisfied. And what are the conditions? First, y should not be null. This is the first condition. And second condition is length of x, y should be either less than or equal to the value of n. So now I will be splitting this string into 3 parts. Okay, now how should we split the string into 3 parts? I will randomly say, okay, so let x be equal to, okay, what I will do, I will consider this 3 as x, I will consider this 3 as y, and remaining 2 ones as z. Okay, randomly I am doing this. So x is 3 zeros, y is x is 3 zeros, y is your 0 1 1. Okay, y is 0 1 1, 0 1 1 is your y, and whatever is remaining, that is 2 ones, will be z. Now, is length of y not equal to null? Yes, because y is now a valid string. 3 elements are there in the string, so this is satisfied. Is the together length of xy less than or equal to n? What is the value? What is the length of xy? X length is 3, y length is 3. 3 plus 3, 6. Is 6 less than or equal to n? That is 8. Yes, true. So both these conditions are satisfied. Now, for m equal to 0. Okay, for m greater than or equal to 0. So first I should start with m less than m equal to 0. If that is not working, then m equal to 1 and so on. Okay, for m equal to 0, okay, for m equal to 0, x y raised to m z, okay, can be then written as x y raised to, what is m? M is 0, z. So what will be this string? So when I say x, what is x? 3 zeros, so I will write 3 zeros here. Y raised to 0, that means the component y will be repeated 0 number of times. That means y is not at all repeated, so you are not going to write y. And z, so z will be 2 ones. So what I did, x y raised to 0 z, x is repeated once, y is not repeated, z is also repeated once. So you will get 3 zeros and 3 ones. Now look at the string that we obtained. The valid string in the language, the given language, should be such that number of zeros should be equal to number of ones, first constraint, and second, all the zeros should be written first, and only after all zeros are exhausted, then all ones should come. Now the second criteria is satisfied here. After all zeros, all ones come. But what about the number of zeros and number of ones? There are 3 zeros and there are 2 ones. That means zeros are not equal to ones. That means this is not a valid string of the given language. So you can say this string, it does not belong to n. Therefore, given language L is not regular. Now in this problem, it is asked to prove that the language L equal to w raised to r, where w belongs to 0, 1 star, is not regular. Okay. Now before we actually solve this problem, we need to analyze what is this language. Now w raised to r means what? Suppose the string w, first thing is w belongs to 0, 1, that means any combination of zeros and ones. W is a binary string. So suppose we have w as 0, 0, 1, w raised to r meaning reverse of string w. Always remember, whenever a string has r on top of it, it means whenever the subscript superscript is r, it means it's a reverse of a string. So if w is given to us as 0, 0, 1, w raised to r will be the reverse of it. So w raised to r will be 1, 0, 0. Okay, so this is a language where the string is of type first w will occur and then w raised to r will occur. So all such strings will be accepted. So if w, as I have told you, if w is 0, 0, 1, a valid string in the language should be 001 and 100, where the first half is W and the second half is W raised to R. Okay, so all such strings should be accepted in this kind of language. So now it is asked to prove that this language is not regular. As we have already seen the procedure, the first step is, let us assume the value of n, that's a pumping length. So I say let n equal to, I'll take the value of n as 8. Okay, arbitrarily I am taking it as 8. Then let string w be equal to, I am assuming the value of w. So let string w be equal to say 0 0 1 1. Therefore w raised to r, that's a valid string in the language, will be 0 0 1 1. So that's w, and w raised to r will be reverse of this string. So reverse of the string will be 1 1 0 0. Okay, be a valid string okay, such that length of w raised to r, okay, length of the string w raised to r, this length should be either greater than or equal to n, is greater than or equal to n. Why? Because the length of this string is 1 2 3 4 5 6 7 8. The length of this w raised to r string is 8 and n is 8. So although w raised to r is not greater than it, but it is equal to it, so it satisfies this condition, greater than or equal to. It's not greater than, but it is equal to n. Okay, now let w raised to r be split into 3 parts. X, Y, Z, such that w raised to r can be written as x, y, z, such that the following conditions are satisfied. And what are the conditions? Are satisfied. The first condition is y should not be null. Y should not be null. And second is together length of x, y should be less than n, less than or equal to. Okay, so the string w raised to r, how will I split? Okay, so what I will do is, randomly I am doing this. I am considering this 3 ones as x, this 3 ones and 0 as y, and the last single 0 as z. Okay, so randomly I am doing this. So x equal to 2 zeros, 2 ones. Okay, y will be y will be 3 zeros, y will be 3 ones and 1 0. So 2 0 and okay, x is 2 0 and single 1, not 2 ones. X is 2 0 and single 1. So y is 3 zeros and 1 0. So 3 0 and 1 0, and z is the last 0. So the original string w raised to r is split into three parts. I am just writing this. So x is 0 0 1, y is 3 ones and a single 0, and z is remaining 1 0. Okay, so that's how I have split the string. So then for m equal to 0, because now for the pumping length m equal to 0 n till infinity, for any value of m from 0 to infinity, if I am able to prove x y raised to mz is not belonging to the language, only then I can say language is not regular. So for m equal to 0, x y raised to m z can be written as x y raised to 0 z. So what will be x y raised to z? So x will be repeated once, 0 0 1, y raised to 0 meaning y, when I say y raised to 0, that means y component will not be repeated at all. Y is repeated 0 number of times, that means it is not at all repeated, and z will be single 0. So what you get here is single 0. Okay, now you observe the string. If this is w, is this w raised to r? Right? If first half is w, is this reverse of w? No. So since it is not abiding by the rules of the language, okay, I can easily say that this string that I have got, it does not belong to the language. So I say this string, it does not belong to the language, therefore the given language L is not regular. Okay, now when we talk about prime numbers, okay, which are the prime numbers? So in this example, since n is given as prime, okay, since n is given as prime, it can be prime number is what? Say 1, 2 is prime, 3 is prime, 5 is prime, okay, 7 is prime, and so on. What's a prime number? Prime number is a number that is divisible by itself and 1, and not by any other number. That's very important. A number that is divisible by itself and 1, but not by any other number. So these are the prime numbers. That means n can be any one of these, right? So 0 should be repeated these many number of times only. Then I can say the given string is a belongs to the language. Okay. So now again let n. Now what I am doing here is I am just assuming the value of n equal to 5. Now why 5? Because 5 is also a prime length. Okay. So if n is 5, then let the string w be equal to n is 5. So that means 0 raised to 5. There will be 5 zeros. Okay. Let w be a valid string. Be a valid string. Okay. Such that w should be either as we have seen in the previous example, the length of w should be either greater than or equal to n, and in my case here the value of w is equal to n. That's fine. Okay. Now let w be split into 3 parts. And which are the 3 parts? As follows. Which are the three parts? What I'm saying is, let x be the first two zeros I will consider as x, this 1 0 will be y, randomly I'm doing this, and this last two zeros will be z. You can try some other combination also. So x is two zeros, y is single zero, and z is the remaining two zeros. So this is x, y, z. Okay, such that the condition, that is together length of x, y should be less than or equal to n, and the second condition, that is y should not be equal to null, are satisfied. These two conditions are satisfied. Now for m equal to 0, okay, x y raised to m z can be written as x y raised to 0 z. So that means y component over here will not be repeated. Y component should not be repeated. So what we will have is two zeros, and z is also two zeros. X will repeat, y will not repeat, and z will repeat. That means what is the value of x? X is two zeros. Y since y raised to 0, y will not be repeated, and z is also two zeros. Now if you look at this, see what is the length of this string. Okay, length of this string happens to be 4. Okay, now looking at the definition, is 4 prime? 4 is not prime. Okay, here it clearly says number of zeros should be the total number of zeros in the valid string should be prime number of zeros. It can have 1 0, string with only 1 0, string with only 2 zeros, string with 3 zeros, but not 4 zeros, then 5 zeros, then 7 zeros. But we have got a string over here with the length 4, and since 4 is not prime, I can easily say that the string that we have got here, okay, it does not belong to the language. So that means this string, it does not belong to the language. Therefore the given language L is not a regular language. Okay, so this is another example. Why it is not a regular language? Because the string that we have obtained here is of length 4, and 4 is not prime. So 0 raised to 4 we have got here, 4 is not prime. So that means that string which we have got with 4 zeros does not belong to this language. Okay, let's proceed. Now what kind of language it is? You can see two things over here. Okay, the valid strings in this language should be such that the order of A's and B's should get reflected. That means all the A's should get exhausted, only then B's should start. That means all the B's should follow all the A's. You cannot have a string like AB, AB. So after all the A's are over, only then all B's will come. But after B there should not be a A. So this is one rule in the language. And second rule says that number of A's, see A raised to I, B raised to J, such that I should be greater than J. That means the number of A's should be more than number of B's. Okay. So with this, let us start. I just randomly select let n be equal to 7. Okay. So accordingly, let the string w be equal to, I'll just randomly take say 4 A's and 3 B's. Why 3 B's? Because the language demands that the string should have more number of A's and less number of B's. So let w belong to L, okay, be a valid string. Okay, now let w be split into three parts, okay, as follows. Okay, now I randomly do this. What I'll do is this first a I will consider as x, then the remaining 3 a's which are there I will consider as y, and whatever remaining 3 b's which are there I will consider this as z. Okay, let's check whether this works. So as follows: x will be single a, y will be 3 a's, and z will be 3 b's. So let's say this is the split that I've done, such that y should not be null, and y is not null because y happens to be a valid string here, and together length of xy, okay, should be less than or equal to n. What is the together length of xy in my case? X one element, x has only one element, y has 3 elements, so together length of xy happens to be 4, and 4 is definitely less than 7, so it is satisfying. So that these two conditions are satisfied. Okay, these two conditions are satisfied. Then for m equal to 0, let's see x y raised to m z, how it will be. It will be x y raised to 0 z, right? Now that means y component will not be repeated here, so x will be single a, y component, that is 3 a's, won't be repeated at all, and z will be 3 b's. Z will be 3 b's. So now looking at this particular string that we have got, we are sure, and it is very clear, that a valid string of the language is such that all a's should get exhausted, only then b should start. Now this condition over here, after all a's only b will start, that condition is satisfied here. But the second condition, the number of a's should be more than number of b's. What do you observe here? There is a single a and there are more b's. As a result, I can say that this string does not belong to the given language, right? So this shows that this particular string here, it does not belong to the language L. Therefore, okay, L, the given language L, is not a regular language. So this is how you can actually solve pumping lemma problems. Pumping lemma problems, solving, as far as solving is concerned, they are very easy, and it's a very scoring topic. Usually they ask you to prove, they will give you a language and they will ask you to prove that the given language is not regular. You should keep a watch on this word. If they ask to prove that something is not regular, not is very important, then you should use pumping lemma. If they ask you to prove that something is regular, then you can try drawing automata and prove that it is a regular or what. Okay, so with this I end today's topic. Thank you.